In this short video, we will learn how to solve a third-degree price discrimination problem when our firm has a constant marginal cost. Let's imagine that VertiQuest, a rock climbing school with some market power, faces two distinct demand curves. The demand by locals is given by Q equals 400 minus 0.5p, and the demand by others is given by Q equals 500 minus 0.5p. So just so we're clear, in this case, L is indicating locals and O is for others. We are also told that the marginal cost of serving either locals or others is constant at $100 and the school has no fixed costs. Now let's suppose that VertiQuest can distinguish between the two types of customers and they choose to engage in third-degree price discrimination. Our goal is to determine the profit maximizing quantity and price for each market. So what do we need to know to solve this question? We need to know each market's demand or inverse demand curve, and we also need to know the firm's marginal cost function. How do we solve this question? Well, because there's a constant marginal cost, the question is actually quite simple to solve. We are just going to set each market's marginal revenue equal to the constant marginal cost and solve for Q, and then use inverse demand to set the price. So effectively, we're solving two monopoly problems at once, one for locals and one for others. And the fact that we can separate this into two separate problems is because of that constant marginal cost. So let's solve this question. Here's what we know. We have demand curves for each market as well as our marginal cost of 100. And our goal here is to find the profit maximizing price and quantity for each market. So we know that we can solve separately because of the constant marginal costs. Let's start with locals. We are going to find inverse demand, then total revenue, and then marginal revenue. So to find inverse demand, we look at our demand curve and we invert. We solve it for P. So we have, let's see, 0.5p is equal to 400 minus Q. And then to get rid of this 0.5, I multiply both sides of my equation by 2. So I have P is equal to 800 minus 2Q. Now that I have my inverse demand, I can find total revenue, where total revenue is going to depend on Q, and it's equal to inverse demand, 800 minus 2Q, all times Q. If we simplify, we get 800Q minus Q squared. Sorry, 2Q squared. Let me write that again. I'll write it below. 800Q minus 2Q squared. Now it's correct. Finally, we can find marginal revenue. Just as a reminder, marginal revenue is the derivative of the total revenue function with respect to Q. So in this case, marginal revenue, which depends on Q, is equal to 800 minus 4Q. Now that we've found marginal revenue, we can set that marginal revenue value equal to marginal cost to find the number of units that our firm wants to sell to locals. So we have 800 minus 4QL is equal to marginal cost of 100. So 4QL is equal to 800 minus 100, which is 700. If we then divide both sides by 4, we get that QL is equal to 175. Once we know how many units our firm should sell to locals, we can substitute that value into the inverse demand, equation 1, to find price. So the price we should charge to locals is equal to 800 minus 2 times 175. Doing a little bit of math, we get that the price for locals is $450. We are going to repeat this process for others. What does that mean? Well, we're going to find the inverse demand, the total revenue, and then the marginal revenue in the other market, the non-local market. So inverse demand is just a matter of rearranging our demand function here. So we have 0.5p is equal to 500 minus q. Multiplying both sides by 2, we get p is equal to 1000 minus 2q. As we saw previously, total revenue is price times quantity, which we can write as 1000q minus 2q squared. So I'm taking my inverse demand and I'm multiplying it through by q. And then finally, we can find marginal revenue by differentiating that total revenue function with respect to q, and we get 1000 minus 4q. With our inverse demand and marginal revenue function for the other market, we can now find the profit maximizing quantity and then price. First thing we're going to do is we're going to set marginal revenue equal to marginal cost in the other market. So we have 1000 minus 4q is equal to 100. From there, we solve for q. So I move the negative sign over here. 4q is equal to 900. I divide both sides by 4, and I get that q is equal to 225. Once we have that q, we substitute that back into the inverse demand to set the price. We're just acting like a monopolist. So the price that we should charge, or that the firm should charge to others, is equal to 1000 minus 2 times 225. Doing a little bit of math, we get that this price is equal to 550. So the final solution is that VertiQuest should charge locals $450 and others $550. And if they do so, they will serve 175 locals and 225 others. Keep in mind this question was particularly simple because of the constant marginal cost, which allowed us to really solve two separate monopoly questions.